Download this code and get free GPT-4o from codegive.com, link in the description below. Signal Processing Basics in Python, Lecture 1. Overview. Signal processing is a field of study that focuses on analyzing, modifying, and synthesizing signals. Signals can be sound, images, or any other type of data that vary over time or space. In this lecture, we will cover the basics of signal processing using Python, including how to generate and visualize signals. Objectives: understand the basic concepts of signals and systems. Learn how to generate simple signals, sine waves, square waves, etc. Visualize signals using Matplotlib. Understand sampling and the Nyquist theorem. Prerequisites. Before we begin, ensure you have the following Python packages installed. 1. Understanding signals. In signal processing, a signal is a function that conveys information about the behavior or attributes of some phenomenon. Signals can be classified into analog signals, continuous signals that vary over time, example sound waves. Digital signals, discrete signals that are sampled at intervals, example audio files. Example, generating a sine wave. Let's start by generating a simple sine wave, which is a fundamental signal in signal processing. Code example. Explanation. 1. Parameters. We define the frequency, 5 Hz, sampling rate, 100 samples per second, and duration, 1 second. 2. Time array. We create a time array T using np.arrange, which generates values from 0 to 1 second with intervals of \frac1 \text sampling rate 3. Sine wave generation. We compute the sine wave using the formula \text sine _wave equals \sin, 2 pi ft, 4. Plotting. We use Matplotlib to plot the generated sine wave against time. 2. Sampling and the Nyquist theorem. The Nyquist theorem states that to accurately reconstruct a signal, it must be sampled at least twice its highest frequency component. This is known as the Nyquist rate. Example, sampling a sine wave. Let's visualize how sampling affects a sine wave. Code example. Explanation. 1. Sampling rates. We define 2 sampling rates, one below the Nyquist rate, 10 Hz, and one above, 50 Hz. 2. Time arrays. We create time arrays for both sampling rates. 3. Sine wave generation. We generate the sine waves for both sampling rates. 4. Plotting. We use a stem plot to visualize the sampled sine waves, demonstrating how the sampling rate affects the representation of the signal. Conclusion. In this lecture, we covered the basics of signal processing, including the generation and visualization of signals, as well as an introduction to sampling and the Nyquist theorem. In subsequent lectures, we will explore more advanced topics such as filtering, Fourier transforms, and applications in audio and image processing. Next steps. Experiment with different frequencies and sampling rates. Explore how to add noise to signals and visualize the effects. Feel free to reach out with any questions or for further clarifications.